Okay, if you've been watching along my videos, you've seen the definitions of the operations of addition, subtraction, multiplication, and now it is time to sow the seeds of division. Right? Division is the inverse operation of multiplication in very much the same way, but subtraction is the inverse operation of addition. Right? So we're going to look at two more definitions of division. Division has three definitions in very much the same way, but subtraction has three definitions. All right, so let's look at this addition and subtraction relationship again. Right? If I have some total length, let's call that T, and I split it up into two pieces, A and B. The idea of a total is that A plus B is going to give us the total, right? The sum of these smaller pieces tacked onto each other. If we go back to the arrows, right, continue to move. I move A, and then I move B. Or if I flip everything the other way around, I move B, and then I move A, right? I'm still going to get that same amount, right? Well, subtraction, I can either start with the total and take off this B part, right? Move backwards from T backwards by B to get A. And I can describe that by saying, well, T take away B gives me A, right? If I start here, I've moved the total, and then I move back by a certain amount. I reverse direction and then go B backwards. Where do I end up at? I end up at A. I end up where I would have been if I'd started from the beginning and only gone A, right? That's that reverse definition of subtraction. But I could also say, if I'm already at A, right, here's 0, here's A, how far is it to the total? I know the long part, I get rid of the long part to find the short part. Or rather than get rid of, I'm just trying to see how much further do I need to go to get to the end. Right? It's either saying, how far back do I go to get here? How far forward do I go from here to get there? That's this second definition of the distance, the difference between those two values, right? It doesn't really matter if A is the bigger number or B is the bigger number. Just a different way of thinking about it, of moving backwards or looking at the distance between. Right? Two definitions for subtraction, two ways for the same physical picture, two ways to see that A plus B equals a total can be used to get backwards from one smaller value to the other small value. Division is going to work exactly the same way. So let's get a new page here and get rid of this ink. All right. So let's think of a multiplication problem. Instead of addition, let's say 3 times 5. Right? Well, if division is the inverse of multiplication, that's saying 15, that output value, just like T, that product, I'll say in general, A times B equals the product. That product divided by 1 gives me the other, or divided by the other gives me the A. 15 divided by 3 equals 5, or 15 divided by 5 equals 3. Right? In a purely numerical sense, because addition and multiplication are both commutative, seeing these statements isn't immediately give me two different definitions, right? So let's look at a word problem so we can see how that comes into play. Let's say I have 5 bags of croissants. I love croissants. Creme brulee has the best croissants in the city of Philadelphia. I encourage you, look them up. They're in my neighborhood. The baker's a friend of mine. Best croissants in the city. All right, I have 5 bags of croissants. How many croissants are in each bag? Well, 3. 3 croissants are in each bag. How many total croissants? Well, I have 3 croissants per bag. I multiply that by 5 bags. We're going to get to unit conversion later on, but bags cancels, right? I'm left with 3 times 5, 15 croissants, right? The croissants per bag times the number of bags gives me the number of croissants. That's this idea of multiplication, changing my units. My units were bags, but now they're croissants because I know the ratio of how many croissants per bag, right? That unit change is always what's going on with rates, whether that's miles per hour or dollars per ounce or whatever it is, right? We're changing our units from bags to croissants by multiplying. Well, if I want to go backwards, if I say I have 15 croissants, should have picked a shorter word, 15 croissants, that's my total, that's the product here, right? And I can divide that by the number of bags I have. And 15 divided by 5 is 3. 3 croissants divided by bags. 3 croissants per bag, right? And that's what this statement is saying, 3 croissants per bag. So that's one definition of multiplication, or sorry, one definition of division is to say division is the operation that splits the dividend, and we'll define these jargon words shortly. Dividend, otherwise known as the numerator, to get into fraction formatting, into equally sized pieces. The number of which is given by the divisor. Okay, so let's look at that. We've got some dividend, a starting number, 15 croissants. And I'm dividing that up into equally sized pieces, right? We're assuming each bag holds the same number of croissants. Right? That's not always true when you go to the store, right? But in these idealized situations, we're assuming everything's of uniform size. So we split the dividend into equally sized pieces, the number of which is given by the divisor. How many bags do I have? I have 5 bags. So my quotient is going to give me the result of the size of each bag, right? How many croissants are in each bag. I could have done a different division. Started with 15 croissants. Instead of saying, look, I want to split this up into 5 bags because I'm handing it out to 5 of my friends, I'm just saying, I'm really hungry. I'm going to eat 15 croissants. Give them to me now. And so we don't have any big bags. We only have bags that can fit 3 each. So I'm going to divide that by 3 croissants per bag. right? We can illustrate this. If I have 5 bags, I'm starting with 5 bags here. 1, 2, 3, 4, 5. And I want to get 15 croissants in there. So I've got 1 croissant here, 1 here. All right, then I start over again. 2, 10, 11, 12, 13, 14, 15. All right, so how many croissants ended up in each bag? Ended up with 3 croissants per bag. So 3 croissants per bag. 15 croissants divided by 3 croissants per bag, that's saying, okay, here's my first bag, I can fit 3 croissants in it. Did I use up all my croissants? No, okay. Here's my second croissant, my second bag, and my third bag. All right, so 3 more here, 3 more here. I'm at 9 croissants, that's not enough. So I need another bag. Take out another bag. 12 croissants, I'm getting close. There's a 5th bag. 13, 14, 15 croissants. How many bags did I need? I needed 5 bags, right? I'm told how big each group could be, 3 croissants per bag, and that determines how many bags I'm going to need. That's our third definition of division. So I'm going to have to move this down. Let's actually just start over here. Okay, so division is the operation that splits the dividend, otherwise known as the numerator, into equally sized pieces, the size of which, instead of the number, right, up here we were told how many pieces we have, or we could be told how big each piece is, and that will give us the other, given by the divisor. So when we're dividing, we're almost always thinking about this in terms of units. And so if we go back to nice numbers here, I should have put denominator. Divisor, AKA denominator. All right, so when I look at 15 divided by 5 to get 3, I can write that in terms of a numerator being divided by the denominator to give me the quotient, or it could say 15 divided by 5 to get 3. Then it's not as clear why these have the names they do, or we can get into long division format. 15 divided by 5 gives us 3. Right? But in all of these cases, this big number here that we're starting with, and it's not necessarily going to be a bigger number. We can have division where we have 5 divided by 15, and that'll give us a third as our answer. Where in this case, 5 is the numerator or the dividend, and 15, the bigger number, is the divisor or the denominator, right? But we'll talk more about that when we look at fractions. For now, the number we're starting with, the total, the product, right? That big number is the dividend. The number it's being divided by is the divisor. You could think of, in English, often words that end with or is like the actor, the person who's doing it, right? So that's why it's called actor. The perpetrator is the one who perpetrates. The divisor is the one who devises. He's the one who's splitting up that number that was just minding his own business, right? Those 15 croissants are just sitting there on the counter. And then here came the shopkeeper and said, no, I want 5 bags. So we're going to split you up into 5 pieces, five different compartments. So there's a divisor, right? The results, the answer, so to speak, the output is the quotient. So when we're doing long division, the quotient is what's up top. Because these are formal definitions, I feel obligated to write them for you. So for division, the quotient is the output value, the operation of division. That's the same format as our other output values of sum and difference and product. The dividend is sort of the starting number, the one being divided up, as the divisor is the splitting number, doing the dividing. It's always going to be the second, I should say the number after the division symbol, whereas the dividend is the number in front of division symbol. Right? That placing isn't the definition, it's just how we understand, right? When I write 5 minus 3, I recognize I'm starting with 5 and I'm backing up 3. I'm counting down 3 to get to 2. That's not the same as if I started at 3 and moved down by 5. Similarly, if I have 6 and I divide by 3, I'm starting with 6 and then I'm cutting that up into 3 pieces. Each one is 2 inches long, right? Or I'm starting with a 6-foot board and I'm cutting that into 3-foot boards. How many boards can I get? I can get 2 of them. Right? So the units definitely come into play as to what, which of these numbers have what units. We'll see that with each word problem. But here's our divisor after the division symbol. Here's our dividend, number before the division symbol. And here's our quotient. Right? So I think those are all the definitions we have for division. So we've seen that division is not commutative. It's also not associative, right? If we're taking something and dividing it into groups and then subdividing those into groups, we do have to go in order in a particular way, right? So if I have 120 divided by 2 divided by 2, I can't say, well, 2 divided by 2 is 1, so that's 120 divided by 1, which is 120. No, I'm saying 120 divided in half is 60, and then half of 60 is 40, right? We've got to do each division in turn. Oh, half of 60 is not 40. Half of 60 is 30. I think maybe it means it's time to end the video if I'm making these silly mistakes. Right. Do my first division, then my second division. Half of 60 is 30. There we go. All right.